So actually they have given 3 examples here itself. So in this, the first one, the first name of the salt comes from the base and second names come from the acid. So calcium is the base, so calcium hydroxide is the base. And HCO3 is coming from the acid, so H2CO3 is the acid. The next NaNO3. In NaNO3, sodium part is coming from the base and NO3 coming from the acid. So which acid will contain the NO3? Base is the NaOH and the acid is the HNO3. Okay. So NaOH is the base and the acid is the HNO3. In the magnesium phosphate, what is an acid and what is the base? First, what is the formula of magnesium phosphate? What is the formula of magnesium phosphate? Can you hear my voice or not?
Yes, sir, we can hear you.
Then what is the formula for magnesium phosphate?
Sir, magnesium hydroxide, Mg3PO4 taken twice.
Mg3PO4 taken twice. So magnesium coming from the base. So magnesium hydroxide formula.
Sir, magnesium hydroxide and phosphoric acid.
MgOH taken twice. And PO4 is coming from the acid. So it is a H3PO4 orthophosphoric acid. So this is how you'll identify the acids and base from the given salt. Is it clear now? Or still anybody has any doubts? Is it clear for everyone or still anybody has any doubts? If you have the doubts, now you can tell me frankly without
No
feeling
doubts.
timid or shy. I will give you some more examples and will explain you. Any one of you, if you have the doubts, I'll explain you once again. Feel free to tell any doubts, or you can keep the text message to me. So that I didn't understand, I have the doubt. I will give you some more examples and I'll explain. No doubts or any doubts is there?
No doubts, sir.
No, sir.
Okay. So next one is the family of salts. What is the meaning of family?
Like same element.
Family. Family means there should be some common things among the group of people, right? So group of people will be there. There should be some common thing among all the people. That is called as in family. So family of salts also same. There should be a common cation or there should be a common anion among the given salts. That is called as in family of salts. Understanding? Suppose if you take sulfate family. Okay. The sulfate family salts are Na2SO4, K2SO4, MgSO4, CaSO4. What is the common among all the salts?
Sir, SO4, sir.
Sulfate. Sulfate is the common among all the salts. So all these are the family of sulfate family. Okay. All these salts are the belongs to sulfate family. Like that, if you take the chloride family. Tell me some examples of salts belongs to chloride family. Give me some examples of salt belonging to the chloride family.
So can you hear me, sir?
Yeah, I can hear you. Now only I can hear you.
Actually, I was speaking some 5 minutes. Sir, what is like in salts we have families, sir?
Yeah, I can hear you now only from now. Okay, from past times I didn't hear you. Family
Yes.
means what? There should be some common among the members. Suppose sodium sulfate is there, potassium sulfate is there, magnesium sulfate is there, calcium sulfate is there. Among all these four different types of salt, the common thing is sulfate ions. There is an anion.
Yes, sir.
So that's all belongs to sulfate family. Like chloride family is there. That means the chlorine ion should be common among all the salts, right?
Yes, sir.
Now tell me what examples for this one.
So NaCl?
BaCl2,
CaCl2,
KCl,
KCl,
Sir, HCl.
HCl, but HCl is an acid, right? It's not the salt. I want the salts, not the acids. LiCl, MgCl2, whatever the thing it is, AlCl3, all these are the salts. Salt means what? There should be cation and there should be anion. The cation should be different from the H plus and anion should be different from the OH minus. Remaining all will form the salts. Is it clear now?
yes sir.
Or anybody has any doubts in this? If you are clear, we are going to other topic.
Done sir.
Okay. So now we'll study the different types of salts. The important salts are there in this chapter. The first one you know already. Common salt. What is a common salt? What is common salt? The sodium chloride is called
Sodium NaCl.
you can call it as a common salt. Or what is the other name?
Yes.
Rock salt. Okay. So generally, you know, we will get the common salt from the evaporation of the seawater, right? What is the most common source?
Seawater.
Evaporation of seawater. So when you are getting the common salt or when you are getting the NaCl from the evaporation of seawater, it is generally pure in nature and you'll get pure white color salt. But at the same time, you'll get the sodium chloride in the form of deposits in the earth crust. So when you're getting the sodium chloride from the earth crust, it will be mixed with some impurities present in the soil. So generally the type of salt will have the brown color. That is only called as a rock salt. Okay. So common salt or rock salt both are same only, but rock salt is the one which you are getting from the earth crust, and common salt both are same only composition, but common salt you can say to obtain from the evaporation of seawater. And you have seen in lower standard textbooks how you'll get the sodium chloride from the evaporation of seawater. They'll take the shallow pits and they'll allow the sun rays to fall so that after 10 days, whatever the water is, it will evaporate and only salt deposit will be left out in that shallow pits. You have seen the image or not?
Yes, sir.
Yes.
Next important properties, the properties of common salt. Tell me anyone, what are the properties of common salt?
Soluble in water.
Soluble in water. Good. How much? You know the unsaturated solution, saturated solution, supersaturated solution, right?
Yeah sir.
So what is the saturation point for the common salt? 36 grams in 100 ml of water. The first property of common salt is it is a colorless crystalline solid with a melting point of 820 degrees Celsius. So it is a crystalline solid with melting point. What is the meaning of melting point? What is the meaning of melting point?
So the temperature at which a state there is a change of state, sir, from solid to liquid.
Temperature at which the solid is converting into the liquid. Okay. So at the lower temperature, generally 0 to minus 20 degrees Celsius, it will exist in the form of dihydrate, that is NaCl.2H2O. Okay. Same the common salt will exist in the form of dihydrate. 2H2O molecules will be there. Next third one. It is slightly hygroscopic in nature. What is the meaning of hygroscopic in nature? What is the meaning for the hygroscopic? Anyone? When you keep the common salt in the outside atmosphere, open atmosphere, what will happen? Whether it will absorb the water or not.
Yes, sir.
Hygroscopic means absorbing the moisture from the surroundings. It will not become completely liquid and all, but it will absorb little moisture from the surroundings and make semi-liquid. Have seen this? When you put the common salt in the outside atmosphere or in a plate for some time, it will absorb the moisture from the surroundings and become the semi-liquid. And as Singham said, it is soluble in water. Okay, the saturation point is 36 grams in 100 ml of water. This is the saturation point. Fine. Any doubts in this?
No doubt. Sir, a small doubt, sir.
Yeah,
If we heat the water, then can we increase the saturation point?
you can increase the saturation point.
Okay, sir.
As you increase the temperature, the solubility of the solid will increase.
Okay, sir. Yeah.
But as we increase the temperature, the solubility of the gas will decrease. These are the two opposite points.
Yeah, sir.
Suppose if you take the NaCl itself, if you dissolve in the hot water, more amount of NaCl will dissolve than the room temperature one. But when you take the oxygen content in the warm water is more or cold water is more?
So warm more.
Oh, cooled water. Oxygen will be in the more in quantity in the cool water than the warm water.
Oh, okay, sir. Yeah.
Because the gas solubility will decrease with increase in temperature, but solid solubility will increase with increase in temperature. Good.
Okay, sir.
Okay. The next one, you have to tell the uses. What is the use of common salt then? Come on, give me the general answer at least. I'm not scolding you, right? Fast.
Sir, it has a salty taste.
Generally, it is
Yes.
used as a constant of our diet, right?
Yes, sir.
Next, good. Next, it is used to make freezing mixture. Okay, that means when mixed with ice, it will form the freezing mixture. So if you go for the street foods, in summer season, they'll keep one roller. Inside the roller, they'll keep some ice and they'll add the salt. And above the roller, they'll keep the ice creams and all. Anybody saw this? No?
No, sir.
Okay, no issues. So it is helpful in making the freezing mixture. The third one, it is a basic raw material for preparation of caustic soda.
Present food.
Sorry,
Present food.
So what is this freezing such or freezing? It is used to make
freezing mixture.
okay.
So it is a basic raw material for preparation of caustic soda. What is the formula for caustic soda? Formula for caustic soda.
NaOH.
NaOH. Good. Sodium hydroxide is called as caustic soda. So NaCl is a basic raw material for the preparation of caustic soda, baking soda, and the washing soda. Washing soda formula
Na2CO3.
Na2CO3. Any doubts in this? Sodium chloride. Any doubts in sodium chloride?
No, sir.
The next important salt is the caustic soda.
Sir, so washing soda and baking soda, these all comes under salts only.
Yeah,
Which we use in our daily life.
yeah.
So where will be using this caustic soda?
Caustic soda will be used in degreasing of metals or preparation of artificial fibers. You know the rayon, right?
Yes, sir.
In the preparation of rayon, also we'll use the caustic soda, or as a laboratory reagent, preparation of soaps and detergents.
Yes, sir.
Generally, whatever the soaps you're using, it is prepared with the help of potassium hydroxide or sodium hydroxide. And detergent bars also will use prepare this. Okay,
Yes, sir. Yes.
so we'll study individually one by one. So first, caustic soda is nothing but the sodium hydroxide. So how will prepare the sodium hydroxide? First, what is the meaning of brine solution?
Sorry, sir.
Brine solution.
Highly concentrated water solution with common salt.
Brine solution.
So is it BRID braid? Brain.
Not
Okay.
bride and all. Brine. BRINE.
Okay.
Okay. So brine solution is nothing but the aqueous solution of sodium chloride. Simple. When you add the salt, NaCl salt in the water, it will form the brine solution. Okay.
Yes.
So when you're electrolyzing the brine solution, you'll get the sodium hydroxide. So if you have finished this method, you can see one electrolysis bath in the textbook. It will be clear in that. I will show you that also. So this method is also called as a chlor-alkali process. This method is also called as chlor-alkali process. What is the meaning of alkali? Anyone?
The base soluble in water.
Alkali means what?
Base that is soluble in water.
Base which is soluble in water is called as an alkalis. First, everyone is understanding my handwriting or not?
Understanding, sir.
Okay, thank you. So chlor-alkali process, because after the preparation of sodium hydroxide, we'll get the chlorine as a byproduct and alkali, that is a sodium hydroxide, as a main product. Okay, the main equation part is this. 2NaCl, that is in the aqueous format, plus water upon electrolysis. Electrolysis means what? On passing of electricity, you'll get sodium hydroxide, that is a caustic soda, along with the chlorine gas, and along with the H2 gas. Clear? This is the equation part for the preparation of caustic soda or the sodium hydroxide. Okay. Clear the equation part? Is it clear or not? No response.
Clear, sir.
Because sir is asking 2 or 3 times right continuously. So at least if you say clear na, he'll not ask again. That's what you are feeling, right, everyone? Tell yes or no, at least for the head.
No, sir, I'm writing the thing.
So writing the notes. Okay. Just wait a minute. If you finish now, I will show you the textbook.
Sir, did you share yesterday's recording or notes, sir?
No.
So can you just share today, sir? Actually, yesterday I couldn't write the notes, sir, but I was in the class. I was actually in my relative's house, sir.
Okay, okay. But the main problem is after the class, I'm going to the hospital, so I couldn't find the time.
Sir, you can like take your time to after 2 days also. Please
Yeah.
share.
I will share, Pakka, I will share, but it will take some time. That's what.
Okay, sir. No problem.
Okay.
Sir, like by Sunday, can you
Yeah, I
post?
will do. By Sunday, I will try maximum.
Okay, sir. Thank you.
Okay, Aditi. So if you have copied this, I'll open the textbook. Can I wait for you to copy?
1 minute. Yes, sir. Done.
Okay. Just wait a minute. Can you see the textbook now? Can you see the textbook?
Yes, sir.
Okay. Now this is the electrolysis bath. Sorry. So this is the electrolysis bath. So in that they are passing the brine solution from an end. Okay. So brine solution is nothing but the aqueous solution of sodium chloride. So that is the brine solution. They're passing the brine solution from this end. Now they have the two electrodes. One is the anode, the other one is the cathode. Anode means what? The positive charge electrode, which is connected to the positive terminal of the battery. Cathode is the one which is connected to the negative terminal of the battery. Okay. Clear up to this? So anode is the one which is connected to the positive terminal of the battery, and cathode is the one which is connected to the negative terminal of the battery. Fine. Now, when you are passing the electricity, the NaOH, the NaCl and H2 will break into the NaOH and Cl2 and the H2. If you take H, it will form H plus ion, that is a positive charge. And if you take Cl2, it will form Cl minus ion, it is a negative charge. So positive will go and attract the negative charge electrode. This is a negative charge electrode, right? So positive will go and attract the nearby the negative charge electrode. And the chlorine is a negative charge will go and attract near the positive charged electrode. Are you understanding this one? Can you hear me?
Yes.
Yes, sir.
This is the previous year question. Last
Sir,
time we got
it's a type of electrolysis only, right? We
it is
have learned in
electrolysis
the
process only, but in that last year question, what they asked in the MCQ. So during the chlor-alkali process, near the cathode, which gas will be formed? That is the question. Near the cathode, which gas will be formed? Hydrogen, chlorine, okay, NaOH or none of this? What is the answer?
hydrogen.
Hydrogen gas will be formed near the cathode. For your remembrance, how you can remember? Cathode is a negative charge particle, sorry, negative charge electrode. It will attract the positive charge gas. What is the positive charge gas here? H plus. This is a hydrogen. Anode is a positive charge electrode. It will attract the negative charge gas, that is the chlorine. Fine.
Yes.
So continuously upon the sending of the brine solution from one end, we'll remove that after the electrolysis also we'll remove the brine solution which contain the NaOH. Okay, so there is a electrolysis process. So when you're passing the electricity with the help of battery from here, two electrodes will pass the electricity. Brine solution undergoes the electrolysis process. So NaOH will get here, H2 and the Cl2. So this is called as a chlor-alkali process. Fine, clear this one? Any
Yes.
doubts? Okay. So what is the use of NaOH then? What is the use of NaOH? It is used in the degreasing of metals. You know the grease, right? To reduce the friction we'll use in the vehicles wherever the joints are there or bearings are there. So NaOH will be used to degrease the metals. It is used in the preparation of soaps and detergents. It is used in the paper making industry and preparation of artificial fibers. These are the uses of NaOH. Can I write it there in the notepad or is it enough?
Write in the notepad.
Write in the notepad. Then what about the Cl2? Where we use the Cl2? What about the Cl2? So generally we'll go for the swimming pools, right? In that they will pour the Cl2 liquid to avoid any infections, skin diseases. So Cl2 will be used in the water treatment, swimming pools, PVC, polyvinyl chloride plastics as a disinfectant, or in the preparation of CFCs and the pesticides. These are the use of Cl2 gas. And H2 gas will use in the fuel, margarine. Margarine is nothing but the preparation of vanaspati oil or vanaspati ghee. Ammonia for the fertilizers. These are the uses of H2 gas. Any doubts in this diagram? Any doubts in this diagram?
No.
So,
Yeah.
so why didn't Na and could you go back to the last slide, sir? Last slide.
Yeah.
So why didn't H plus and OH minus, I mean Na and OH minus evaporate?
Why didn't these two will evaporate?
Yes, sir.
Okay. Because you have to form the major product as NaOH only, right?
Yes, sir. But why didn't it evaporate like H2 and Cl2?
Na is not the gaseous state.
Okay,
Okay.
sir.
H2 is in the gaseous format, so it will go to the top of the beaker for the electrolysis part. And Cl2 is also in the gaseous format. But when you
Okay.
take the NaOH is in the liquid format, just combine with the brine solution only, right?
Okay, sir.
Clear?
Yes, sir.
If any with the solid, it will relate to the bottom of the beaker. But this is a liquid, right? So it will flow along with the brine only. These are the two gases. Gases means always try to escape upwards. These two will escape in this direction. The two different types. Okay.
Okay, sir.
So this is a caustic soda preparation electrolysis process. The next one is the uses. What are the uses? You have to tell the answer now. What are the uses? Use it for making soaps and detergents. Next, for degreasing metals. Third one, in making artificial fibers. Fourth one, in petroleum refining. One as a laboratory reagent. Okay, so these are the uses of NaOH. Fine. So next one is the bleaching powder. Anybody knows the formula for the bleaching powder?
So some is CH3.
CaOH twice plus Cl2 gives CaOCl2 plus H2.
Good. Simple method. So it is prepared by the action of chlorine gas and the dry liquid lime. It is prepared by the action of chlorine gas and dry liquid lime. So liquid lime formula is nothing but the calcium hydroxide. When reacting with the chlorine gas, okay, it will form the CaOCl2 plus H2. So this is only called as bleaching powder. Okay,
So CaOCl2 is bleaching powder, sir, or the
CaOCl2 is only the bleaching powder.
okay.
This is a simple formula. Okay, so that's all about the preparation of the bleaching powder. So in which plant this preparation is taken place? It is called as present clever plant. So there's a special name for the preparation of bleaching powder, that is called as method name is called as present clever plant. You see, present clever plant. This is the plant where we'll prepare the bleaching powder. Now tell me, what is the use of bleaching powder? Where we use the bleaching powder?
Clothes.
In textile industry, we'll use the bleaching powder for bleaching of cotton and the linen.
Used for disinfection of water.
Used as a disinfectant in the water. Next one is for disinfecting the drinking water. Next, any other? In laundry, bleaching for washing clothes. Next,
Oxidizing agent.
oxidizing agent. Okay, General uses you can tell me. General baking powder you don't use as oxidizing agent. In paper industry also we'll use this baking powder for baking of pulp. Okay, these are the use of baking powder. The next one is a baking soda. So baking soda is the most common word used in the kitchen, right? For the preparation of any snack item.
NaHCO3.
NaH,
CO3.
Sodium bicarbonate.
NaHCO3 is the baking soda. How will prepare the baking soda then? Take the NaCl and react with the H2
Water,
plus
carbon dioxide and ammonia.
carbon dioxide and the ammonia. Very good. To form
Ammonium chloride and sodium hydrogen carbonate.
sodium hydrogen carbonate and ammonium chloride. Very good. So this is a method for preparation of baking soda. So this process is called as an solvay process. What is the process name? Solvay process. Okay. Then what is the difference between the baking soda and baking powder? What is the difference? Both are same.
Sir, for making baking powder, we have to use baking soda, and in that we have to mix edible acid
Why?
to form baking soda.
No.
Sir,
Why?
and
Why you want to add the edible acid?
sir, I think in the baking powder we will add slaked lime, sir. And here we are adding common salt.
Someone said the answer is correct. Who is the edible acid?
Sir, Nihal.
Nihal, good. Whatever you said is correct, but why you are adding the edible acid here? See, baking soda is in a base actually. Yes. Baking soda is the base. Base means what? Bitter in taste, right? So we can't use the bitter taste in the preparation of cakes and all. Cakes are generally sweet in taste. It's not soda, it's not sweet, bitter. It's just sweet in taste. So to avoid the bitter taste in the cakes, we'll add the baking powder, not the baking soda. So baking powder is nothing but the baking soda plus edible acid. Mostly we'll take the tartaric acid. Okay, so this acid will remove the excess base or will remove the bitter taste of the baking soda and form the neutral one. Understanding? Edible acid or the tartaric acid is added to the baking soda to remove that excess basic nature or to remove the bitter taste to form the neutral powder. So baking powder is used in the preparation of cakes. Fine. Any doubts in this? Up to this?
No doubt, sir.
Today what we started to discuss today? Sodium chloride, caustic soda, sodium hydroxide, bleaching powder, and the baking soda. Fourth one, right? Okay, there are the four salts. The remaining washing soda is there. Plaster of Paris is there. Okay, these two is left.
Gypsum also is there, sir.
Yeah, in the plaster of Paris, we'll study about the gypsum. And what is the water of crystallization is there. After that, small topics are there. What is the common among of all the acids? What is the dehydrating agent and all? Okay, with this we'll finish the chapter. Fine, we'll end the class here today. If you have any doubts, you can ask me, or else we'll end the session.